In this video, I'll demonstrate a way to approximate the constant e as the future value of a dollar. At one point, I was told e is an irrational number. At the time, I didn't know what this meant, but really, irrational just means you can't write the number as a ratio, like 19/7. The number e comes from the limit of a calculation that can go on and on. E is the fastest something can grow, so e comes out of growth problems. For example, if you have a quantity of 2 rabbits today, how many rabbits will you have in a year starting from those 2 rabbits? Or say you have $100 today, how much will you have in a year? In this tutorial, we'll use the money example and we'll step through how to calculate an approximation of E as a compound interest problem. Let's talk about doubling your money. Let's look at an investment that gives you 100% interest over one period. You start with $1. You earn $1 interest over the course of the period. At the end of the period, the interest gets added to your starting dollar and you end up with $2. That's a pretty good return, but maybe we could get more. Maybe we could divide our 1 year into 2 6-month periods, and instead of earning 100% interest, we'll earn 50% during the first period. I'll end up with $1.50, and we'll earn 50% during the second period, which will give us 75 cents for a grand total of $2.25, and that's even better. But let's try to earn even more. What if we divide it into 4 periods? We'll get 25% interest per period, and we'll get paid over the course of a year 4 times, and we'll get even more money. So the question is, if we keep going through this process, what's the most that we can get? And if we look at this process, we're just taking our 1 plus our rate of return for the period and continually multiplying it with our starting value. So if we want to break this up into even more periods, we can put it in this form, and we can generalize it into this equation. So now, instead of 1, 2, or 4 for n, our number of periods, there's just another table showing 1, 2, or 4 as our number of periods. Our interest, as we increase the number of periods, goes down, and our future value seems to be going up. But how high will it actually go? Will it just keep going on forever, or is there some limit? So what if we have 1,000,000 periods with 1/10,000th of a percent interest paid out during each of those million periods? How much money will we actually earn on our investment at the end of a year? Well, the answer is $2.71 and a bunch more decimal places. But actually, up through here, this number, up through the 8, is a pretty good approximation of E, which is the natural growth constant. And the value is approximately 2.718281828. So if we, starting amount multiplied by E represents the maximum future amount that can result from 100% continuous growth over a single time period. And so the continuous part is that dividing into smaller and smaller intervals until it's smooth. And so that's the example of how to calculate E as the future value of a dollar. Thanks.